What if the universe is hiding worlds so strange they make science fiction look tame? Picture this: planets where it rains molten glass, where diamonds cover the surface, or where a year lasts just 2 hours. These aren't scenes from a movie, they're real exoplanets, worlds beyond our solar system, and they're rewriting everything we thought we knew about the cosmos. In this video, we're diving into 20 of the most bizarre exoplanets ever discovered. From scorching lava worlds to icy giants drifting alone in the void, these discoveries challenge our understanding of space and hint at the endless possibilities of what lies beyond. So buckle up, because by the end of this journey, you'll see the universe in a whole new light. Let's explore these alien worlds together. Now turning to our first bizarre exoplanet, let's explore the Diamond Planet, officially known as 55 Cancri. Imagine a world where the ground beneath your feet isn't made of rock or soil, but of graphite and diamond. This carbon-rich exoplanet, located about 40 light-years from Earth, is one of the most extreme worlds ever discovered. Its surface is believed to be covered in layers of diamond, making it a glittering, otherworldly gem in the cosmos. But don't let its beauty fool you, this planet is a scorching inferno. Orbiting incredibly close to its host star, 55 Cancri completes a full orbit in just 18 hours, and its surface temperatures can reach a staggering 2,700 degrees Celsius. That's hot enough to melt most metals. What makes this planet even more fascinating is its extreme density. Scientists estimate that about a third of its mass could be pure diamond, a result of its carbon-heavy composition and the intense pressure within its core. To put it into perspective, Earth's geology is dominated by silicates and metals, but 55 Cancri is a carbon-based world, making it a stark contrast to anything we've ever seen. Its molten surface, constantly reshaped by the extreme heat, creates a landscape that's both alien and mesmerizing. This discovery challenges our understanding of planetary formation and composition. How did a planet like this come to be? What processes could create such a diamond-rich world? As we continue to study 55 Cancri, it reminds us that the universe is full of surprises, and even the most familiar elements like carbon can form worlds that defy our imagination. Now shifting our gaze to another cosmic marvel, let's dive into the Puffy Planet, officially known as HTP-1b. Picture a gas giant so enormous and lightweight that it seems to float like a balloon in the vastness of space. This exoplanet, located approximately 450 light-years from Earth, is one of the most peculiar discoveries in recent years. Unlike the dense, compact gas giants we're familiar with, such as Jupiter or Saturn, HTP-1b is incredibly low density, so much so that if you could find a bathtub large enough, it would actually float in water. What makes this planet truly baffling is its inflated atmosphere. Scientists believe that its extreme size, nearly 1.5 times the diameter of Jupiter, is due to intense heat from its host star, which causes its atmosphere to expand like a hot air balloon. This phenomenon challenges our traditional models of planetary formation, as it suggests that some gas giants can grow far larger than expected under certain conditions. Adding to its uniqueness, HTP-1b orbits its star at an unusually close distance, completing a full orbit in just 4.5 Earth days. This proximity means the planet is constantly bombarded by stellar radiation, further contributing to its inflated state. Despite its size, HTP-1b is surprisingly lightweight, with a mass only about half that of Jupiter. This combination of size and low density makes it a true outlier in the planetary family. The discovery of HTP-1b raises intriguing questions about how such planets form and evolve. Could there be more of these puffy giants lurking in the cosmos? What other factors might contribute to their unusual characteristics? As we continue to study this enigmatic world, it reminds us that the universe is full of surprises, constantly challenging our understanding of what's possible. Now turning to a world that seems ripped straight from the pages of a science fiction novel, let's explore the lava world known as K2141b. Imagine a planet where one side is a scorching sea of molten lava, while the other is plunged into eternal darkness. This exoplanet, located about 200 light-years from Earth, is a true testament to the extremes of the universe. K2141b orbits so close to its host star that its surface temperatures soar to unimaginable heights, reaching up to 3,000 degrees Celsius on its day side. This intense heat causes the rocky surface to melt, creating vast oceans of lava that stretch across the planet. But here's where it gets even more fascinating. Scientists believe that the extreme heat could vaporize rocks, creating a thin atmosphere of rock vapor. Yes, you heard that right. Instead of oxygen or nitrogen, this planet's atmosphere might be filled with vaporized minerals like sodium, silicon monoxide, and even metallic compounds. The night side of K2141b, however, tells a completely different story. Shielded from the star's relentless heat, temperatures here plummet to around -200 degrees Celsius, creating a stark contrast to the molten day side. This dramatic temperature difference drives powerful winds that carry the rock vapor from the day side to the night side, where it condenses and rains back down as molten rock. It's a cycle that's as mesmerizing as it is terrifying. When we compare K2141b to the volcanic planets often depicted in science fiction, it's clear that reality can be just as bizarre as imagination. While fictional worlds like Mustafar from Star Wars capture the essence of a lava-covered planet, K2141b takes it a step further with its rock vapor atmosphere and extreme weather patterns. This discovery not only challenges our understanding of planetary environments, but also sparks the imagination, reminding us that the universe is full of wonders far beyond what we've dreamed up in stories. As we continue to study K2141b, it raises intriguing questions about the limits of planetary survival and the potential for other extreme worlds lurking in the cosmos. What other secrets might these fiery planets hold, and how do they shape our understanding of the universe's boundless diversity? The lava world is a fiery reminder that the cosmos is as unpredictable as it is awe-inspiring. Now shifting our gaze to a world cloaked in shadow, let's uncover the secrets of the dark planet TRES-2b. This enigmatic exoplanet, located approximately 750 light-years from Earth, holds the title of the darkest planet ever discovered. How dark, you ask? TRES-2b reflects less than 1% of the light it receives from its host star, making it darker than coal and even black acrylic paint. It's a world that seems to defy the very nature of what we expect a planet to look like. So, what makes TRES-2b so eerily dark? Scientists believe its extreme blackness is due to its unique atmospheric composition. Unlike planets with reflective clouds or icy surfaces, TRES-2b's atmosphere is thought to be filled with light-absorbing chemicals like vaporized sodium and potassium, as well as gaseous titanium oxide. These elements act like a cosmic sponge, soaking up nearly all the light that hits the planet. But here's the twist: even with these materials, researchers are still puzzled as to why TRES-2b is so exceptionally dark. Some theories suggest that its atmosphere might be missing reflective clouds entirely, or that its surface is covered in exotic materials that absorb light in ways we don't yet fully understand. Adding to its mystery, TRES-2b is a gas giant similar in size to Jupiter, but it orbits incredibly close to its star, so close that its surface temperature reaches a scorching 1,000 degrees Celsius. This proximity means it's tidally locked, with one side perpetually facing the star and the other shrouded in eternal darkness. Yet, even on its day side, the planet remains eerily dim, emitting only a faint reddish glow like a dying ember in the vastness of space. The discovery of TRS-2b challenges our understanding of planetary atmospheres and raises fascinating questions about the diversity of worlds in the universe. How can a planet absorb so much light? What other dark worlds might be lurking in the cosmos, invisible to our telescopes? TRS-2b is a haunting reminder that the universe is full of mysteries waiting to be unraveled, and that even in the darkest corners of space, there's always something extraordinary to discover. As we ponder the secrets of this shadowy world, it's impossible not to wonder what other unseen wonders might be hiding in the depths of the cosmos, waiting for us to shine a light on their existence. Now turning to a world that defies our expectations of what a planet should look like, let's dive into the mysteries of GJ 1214b, often referred to as the water world. Located about 40 light-years from Earth, this exoplanet is unlike anything in our solar system. Imagine a planet entirely covered by a vast, deep ocean with no solid surface in sight. GJ 1214b is a super-Earth, meaning it's larger than our planet but smaller than gas giants like Neptune. What makes it truly unique is its potential to be completely enveloped in water, with a thick, steamy atmosphere that could make it feel more like a giant sauna than a traditional planet. Scientists believe that GJ 1214b's surface might be entirely liquid, with an ocean so deep that it could extend hundreds of kilometers below its atmosphere. The pressure at such depths would be unimaginable, creating conditions where water exists in exotic forms like supercritical fluid, a state where liquid and gas blend into one. This high-pressure environment challenges our understanding of what makes a planet habitable. On Earth, life thrives in liquid water, but GJ 1214b's extreme conditions push the boundaries of where life could potentially exist. Could organisms survive in such a pressurized, steamy world, or would the crushing depths and intense heat make it impossible? Adding to its intrigue, GJ 1214b's atmosphere is thought to be rich in hydrogen and helium with a thick layer of water vapor. This combination creates a greenhouse effect so intense that the planet's surface temperature could reach up to 200 degrees Celsius. Despite this, the possibility of life isn't entirely ruled out. Some scientists speculate that beneath its steamy atmosphere, there could be layers of water where conditions are more stable, potentially allowing for microbial life to thrive. However, the lack of a solid surface raises questions about how life could develop or sustain itself without land or minerals to anchor to. The discovery of GJ 1214b forces us to rethink the concept of habitable zones, the regions around stars where conditions might be right for liquid water and, by extension, life. Traditionally, we've focused on planets with solid surfaces and Earth-like conditions, but GJ 1214b shows us that life might find a way in environments we once thought impossible. It's a reminder that the universe is full of surprises, and that the search for life beyond Earth might require us to expand our horizons far beyond what we currently understand. As we marvel at the possibilities of this oceanic world, it's hard not to wonder what other hidden wonders might lie beneath the surface of distant planets. Could GJ 1214b be home to life forms we've never imagined? Or is it a testament to the incredible diversity of worlds that exist in the cosmos? One thing is certain, this water world challenges us to think bigger and explore further, reminding us that the universe is far stranger and more wondrous than we could ever imagine. Now shifting our gaze to a planetary oddity that defies the norms of cosmic alignment, let's explore Kepler 56b, a world that orbits its star at a jaw-dropping angle. Unlike most planets in our solar system, which orbit their stars in a relatively flat plane, Kepler 56b takes a dramatically different path. Its orbit is tilted at such a steep angle that it almost seems to defy gravity itself. This peculiar alignment challenges our understanding of how planetary systems form and evolve, offering a glimpse into the chaotic forces that can shape the cosmos. So, what causes this extreme tilt? The answer lies in the gravitational tug of war happening within the Kepler-56 system. This exoplanet is part of a multi-planet system, and the gravitational interactions between its neighboring planets and its host star have likely played a significant role in tilting its orbit. Imagine a cosmic dance where the planets pull and push each other, gradually shifting their paths over millions of years. In the case of Kepler-56b, these forces have resulted in an orbit that's wildly out of sync with the rest of its system. This discovery has profound implications for our understanding of planetary formation. Traditionally, we've assumed that planets form from a flat, rotating disk of gas and dust around a young star, leading to orbits that are neatly aligned. But Kepler-56b shatters that assumption, showing us that planetary systems can be far more dynamic and chaotic than we ever imagined. It raises questions about how common tilted orbits might be in the universe and whether our own solar system's orderly arrangement is the exception rather than the rule. The tilted orbit of Kepler-56b also has practical consequences for the planet itself. Its steep angle means that it experiences extreme seasonal variations, with its poles alternately facing the star as it orbits. This could lead to dramatic shifts in climate, with temperatures fluctuating wildly over relatively short periods. Such conditions would make it a challenging environment for life as we know it, but they also highlight the incredible diversity of planetary environments that exist beyond our solar system. As we ponder the mysteries of Kepler-56b, it's clear that this tilted world is more than just a cosmic curiosity. It's a reminder that the universe is full of surprises, constantly challenging our assumptions and pushing the boundaries of what we think is possible. With each new discovery, we gain a deeper understanding of the forces that shape the cosmos and the incredible variety of worlds that exist within it. And as we continue to explore, who knows what other tilted, twisted, and utterly bizarre planets we might find. Now, let's zoom into one of the most extreme environments in the universe with PSRJ 1719-1438b, a planet that redefines the meaning of speed. This exoplanet orbits a pulsar, a highly magnetized, rapidly spinning neutron star, and completes an entire year in just over 2 hours. To put that into perspective, while Earth takes 365 days to orbit the Sun, this planet races around its host star in the time it takes to watch a movie. This blistering pace makes it one of the fastest planets ever discovered, and its existence challenges everything we thought we knew about planetary survival. The pulsar at the center of this system is no ordinary star. It's the remnant of a massive star that exploded in a supernova, leaving behind a dense, spinning core that emits intense beams of radiation. These beams sweep across space like a cosmic lighthouse, and any planet in its vicinity is subjected to extreme conditions. PSRJ 1719-1438b endures not only the gravitational pull of its pulsar host, but also a constant bombardment of high-energy radiation. This raises the question, how can a planet survive in such a hostile environment? Scientists believe this exoplanet might be the remnant of a once larger planet, stripped down to its core by the pulsar's intense radiation and gravitational forces. What remains is likely a dense, metallic world, possibly composed of materials like iron and nickel, forged in the crucible of its violent surroundings. Its close orbit means it's constantly being stretched and compressed by the pulsar's gravity, creating a world that's as dynamic as it is inhospitable. The discovery of PSRJ 1719-1438b challenges our understanding of planetary formation and survival. Traditionally, we've assumed that planets form in the calm, stable disks around young stars, but this exoplanet suggests that planets can also emerge from the chaos of a supernova. It opens up the possibility that planets might exist in even more extreme environments than we ever imagined, from the remnants of dead stars to the edges of black holes. As we marvel at the sheer speed and resilience of this planet, it's a reminder that the universe is full of surprises. PSRJ 1719-1438b isn't just a cosmic speedster. It's a testament to the adaptability of planetary systems, even in the most unforgiving corners of space. And as we continue to explore, who knows what other fast, furious, and utterly bizarre worlds we might uncover. Now, shifting our gaze to another cosmic marvel, we encounter JJ367b, a planet that defies expectations with its sheer density. Known as the Iron Planet, this exoplanet is a compact, ultra-dense world, almost entirely composed of iron. Imagine a planet so dense that its gravity is extreme, pulling everything toward its metallic core with an intensity that would crush anything in its path. Despite its small size, smaller than Earth, this planet packs a punch, challenging our understanding of planetary composition. JJ367b orbits its star in just under 8 hours, making it one of the fastest orbiting exoplanets ever discovered. Its proximity to its host star means it's subjected to scorching temperatures, but what truly sets it apart is its composition. Scientists believe this planet may have once been part of a much larger world, stripped of its outer layers by the intense radiation and gravitational forces of its star. What remains is a dense, iron-rich core, a remnant of its former self, forged in the crucible of its violent past. The extreme gravity of JJ367b is another fascinating aspect. With a surface gravity several times stronger than Earth's, this planet would feel like a crushing weight to anyone standing on it, if that were even possible. Its iron-rich composition also raises intriguing questions about how such a planet could form. Could it be the remnant of a once massive planet that lost its outer layers, or is it the result of a unique process in planetary formation? Either way, JJ367b offers a glimpse into the incredible diversity of worlds that exist beyond our solar system. As we explore this iron-clad world, it's a reminder of the universe's ability to create planets in ways we're only beginning to understand. JJ367b isn't just a curiosity, it's a window into the extreme conditions that shape planetary systems. And as we continue to uncover more about these bizarre worlds, we're left to wonder, what other metallic marvels might be waiting to be discovered in the vast expanse of space? Now, stepping into a world straight out of science fiction, we arrive at Kepler-16b, a planet that orbits not one but 2 stars. This real-life Tatooine scenario, reminiscent of the iconic Star Wars landscape, challenges our understanding of planetary systems and offers a glimpse into the complexities of dual-star environments. Kepler-16b is a gas giant, slightly smaller than Saturn, and its existence raises fascinating questions about how planets form and survive in such dynamic systems. The dual-star system of Kepler-16b creates a unique and ever-changing environment. The 2 stars, one slightly smaller than our Sun and the other much smaller and dimmer, orbit each other in a dance that shapes the planet's climate and seasons. Imagine a world where the sunsets and sunrises are never the same, with 2 stars casting shifting shadows and creating a kaleidoscope of light. The gravitational interplay between the stars and the planet also leads to irregular orbital patterns, making Kepler-16b's year a complex and unpredictable journey. The climate on Kepler-16b is equally intriguing. With 2 stars influencing its atmosphere, the planet experiences extreme temperature fluctuations. One side of the planet might bask in the warmth of both stars, while the other side could plunge into prolonged periods of darkness and cold. These dramatic shifts could create powerful weather systems, with storms and winds far more intense than anything we see on Earth. Yet, despite these harsh conditions, scientists speculate that moons orbiting Kepler-16b could potentially harbor stable environments, raising the tantalizing possibility of life in such a system. The discovery of Kepler-16b not only captivates our imagination, but also expands our understanding of planetary formation. It challenges the notion that stable orbits and habitable conditions are only possible around single stars. As we continue to explore the cosmos, planets like Kepler-16b remind us that the universe is full of surprises, and the search for life may take us to places we once thought were only possible in fiction. What other dual star worlds might be waiting to be discovered, and what secrets could they hold about the diversity of life in the universe? Now, shifting our gaze to the vast, starless expanse of space, we encounter a truly enigmatic wanderer, CFBD Sir 2149-0403, a rogue planet drifting alone through the cosmos. Unlike the planets we've explored so far, this mysterious world doesn't orbit a star. Instead, it roams freely through the darkness, untethered from any solar system. This discovery challenges everything we thought we knew about how planets form and survive. Rogue planets like CFBD Sir 2149-0403 are thought to have been ejected from their original star systems during chaotic gravitational interactions, or perhaps they formed independently in the cold, dense regions of interstellar space. Without the warmth of a nearby star, these planets exist in perpetual twilight, their surfaces likely frozen and inhospitable. Yet, despite their isolation, they hold profound implications for our understanding of planetary science. One of the most intriguing questions surrounding rogue planets is whether they could harbor life. While the absence of a star might seem like a deal-breaker, some scientists speculate that these planets could generate internal heat through radioactive decay or tidal forces from massive moons. If such heat sources exist, they could create subsurface oceans beneath icy crusts, much like those suspected on moons like Europa or Enceladus in our own solar system. This raises the tantalizing possibility that life, in some form, might exist even in the coldest, darkest corners of the universe. The discovery of CFBD Sir 2149-0403 also forces us to rethink the boundaries of habitability. Traditionally, we've focused on planets within the Goldilocks zone of their stars, where temperatures are just right for liquid water. But rogue planets remind us that life, if it exists, might thrive in environments we've yet to imagine. Their existence expands the search for life beyond star systems, suggesting that the universe might be far more diverse and unpredictable than we ever thought. As we continue to explore the cosmos, rogue planets like CFBD Sir 2149-0403 challenge us to broaden our horizons. They remind us that the universe is full of mysteries waiting to be uncovered, and that the search for life might take us to places we once considered impossible. What other solitary worlds might be drifting through the void, and what secrets could they hold about the origins and resilience of life itself? Now, turning our attention to a celestial oddity that seems almost too whimsical to be real, we encounter Kepler-51b, a planet so light and airy it's been nicknamed the Super Puff. Imagine a world with the density of cotton candy floating serenely in the void of space. This exoplanet, located approximately 2,400 light-years from Earth, is one of the most baffling discoveries in modern astronomy. Its incredibly low density defies everything we thought we knew about how planets form and behave. Kepler-51b is part of a system with two other similarly puffy planets, all orbiting a young star. What makes this planet so extraordinary is its atmosphere, which is so expansive and diffuse that it's nearly impossible to comprehend. To put it into perspective, if you could stand on its surface, if it even has one, you'd feel like you were floating in a sea of gas. Scientists believe its atmosphere is composed mostly of hydrogen and helium, with traces of heavier elements, but its exact composition remains a mystery. The planet's extreme puffiness suggests that its atmosphere is bloated, possibly due to intense heat from its star or internal processes that cause it to expand. One of the biggest questions surrounding Kepler-51b is how it manages to hold onto its atmosphere. With such low density, you'd expect its gases to simply drift away into space. Yet somehow this planet has maintained its fluffy envelope for millions, if not billions of years. Some theories suggest that its atmosphere is replenished by outgassing from its interior, while others propose that its distance from its star and relatively calm stellar environment help preserve it. Whatever the reason, Kepler-51b challenges our understanding of atmospheric retention and planetary evolution. This super puff planet also raises intriguing questions about the diversity of planetary systems. Traditional models of planet formation suggest that gas giants like Jupiter or Saturn should dominate, but Kepler-51b and its siblings show us that the universe has a far wider range of possibilities. These planets may represent a rare and fleeting stage in planetary development, where young worlds balloon out before eventually losing their atmospheres and shrinking into more familiar forms. Or they could be a completely new class of planets, one that we're only beginning to understand. As we continue to study Kepler-51b, it reminds us that the cosmos is full of surprises. This cotton candy world, with its ethereal beauty and scientific mysteries, invites us to rethink what we know about planets and their potential forms. What other strange and wonderful worlds might be waiting out there, defying our expectations and expanding our understanding of the universe? The search for answers continues, and with each discovery, we come one step closer to unraveling the secrets of the cosmos. Now, shifting our gaze to a world that feels like it was plucked straight out of a science fiction nightmare, we arrive at WASP-76b, a planet so extreme it defies imagination. This hellish exoplanet, located approximately 640 light-years from Earth, is a place where the skies rain molten iron and the surface temperatures are hot enough to vaporize metal. It's a world that challenges our understanding of what's possible in the universe, and its discovery has left scientists both fascinated and bewildered. WASP-76b is tidally locked to its host star, meaning one side of the planet is perpetually bathed in scorching sunlight, while the other side remains in eternal darkness. The day side of the planet reaches temperatures of over 2,400 degrees Celsius, hot enough to vaporize iron and other metals. These vaporized metals are then carried by supersonic winds to the cooler night side, where they condense and fall as molten iron rain. Imagine standing on the night side of this planet, looking up at a sky filled with glowing droplets of liquid metal. It's a scene that feels more like a surreal painting than a real place. The science behind this iron rain is as fascinating as it is terrifying. The extreme temperature difference between the day side and night side creates powerful atmospheric currents that transport the vaporized metals across the planet. As these metals reach the cooler night side, they cool down and condense into liquid droplets, which then fall as rain. This process is unlike anything we've observed on Earth or any other planet in our solar system, making WASP-76b a unique laboratory for studying atmospheric dynamics under extreme conditions. What makes WASP-76b even more intriguing is how it compares to other extreme exoplanets. While many hot Jupiters have been discovered, few exhibit such dramatic and bizarre weather patterns. This planet's iron rain is a stark reminder of the incredible diversity of planetary environments in the universe. It also raises questions about the limits of habitability and the kinds of conditions that could exist on other worlds. Could there be planets with even more extreme weather patterns, or ones where different elements dominate the atmosphere? The possibilities are endless. As we continue to study WASP-76b, it serves as a reminder of the sheer variety of worlds that exist beyond our solar system. This hellish planet, with its molten iron rain and extreme temperatures, pushes the boundaries of what we thought was possible. It challenges us to rethink our assumptions about planetary environments and inspires us to keep exploring the cosmos in search of even more extraordinary discoveries. What other extreme worlds are out there waiting to be found? The universe, as always, holds the answers. Now, venturing into the realm of cosmic contradictions, we encounter Gliese 436b, a planet that defies logic with its bizarre combination of burning ice and extreme cold. Located roughly 33 light-years from Earth, this exoplanet presents a paradox that challenges everything we know about planetary chemistry. Gliese 436b is a world where ice doesn't melt, it burns. How is that possible? Let's dive into the science behind this extraordinary phenomenon. Gliese 436b is a Neptune-sized exoplanet, but its conditions are anything but ordinary. Despite being covered in ice, the planet's surface is scorching hot, with temperatures reaching up to 439 degrees Celsius. This seemingly impossible scenario is the result of its incredibly dense atmosphere, which is packed with methane. The immense pressure from this atmosphere compresses the ice into a solid state, even at such extreme temperatures. It's like having a block of ice that refuses to melt, no matter how hot it gets. Scientists call this hot ice, a form of water ice that exists under conditions of extreme pressure, something we've never seen on Earth, but the strangeness doesn't stop there. The methane in Gliese 436b's atmosphere doesn't just sit idly by, it burns. The planet's close proximity to its host star causes intense radiation, which breaks down the methane molecules. This process releases hydrogen, which then escapes into space, leaving behind a carbon-rich residue. Over time, this has created a layer of carbon compounds on the planet's surface, adding another layer of complexity to its already puzzling environment. Imagine a world where ice burns and the atmosphere is constantly transforming. It's a place that feels more like a cosmic chemistry experiment than a planet. What makes Gliese 436b so fascinating is how it challenges our understanding of planetary chemistry. On Earth, we're used to seeing ice melt when it gets hot, but this exoplanet flips that idea on its head. It forces us to reconsider the fundamental principles of how matter behaves under extreme conditions. Could there be other planets out there with similarly bizarre properties? The discovery of Gliese 436b suggests that the universe is full of surprises, and our understanding of planetary science is still in its infancy. As we continue to study this enigmatic world, it serves as a reminder of the incredible diversity of exoplanets in the cosmos. Gliese 436b, with its burning ice and high-pressure methane atmosphere, pushes the boundaries of what we thought was possible. It challenges us to think outside the box and inspires us to keep exploring the mysteries of the universe. What other strange and wondrous worlds are waiting to be discovered? The answers, as always, lie among the stars. Now shifting our gaze to a world that redefines the meaning of extreme, we arrive at Kelt 9b, a planet so scorching hot that it outshines even most stars in sheer temperature. Located approximately 670 light-years from Earth, this exoplanet is a true cosmic inferno, with surface temperatures soaring to a staggering 4,300 degrees Celsius. To put that into perspective, that's hotter than some red dwarf stars. But how does a planet become this hot? And what does such extreme heat mean for its atmosphere and overall environment? Let's uncover the fiery secrets of Kelt 9b. Kelt 9b orbits its host star, Kelt 9, at an incredibly close distance, completing a full orbit in just 1.5 Earth days. This proximity subjects the planet to relentless radiation, heating its surface to unimaginable levels. The star itself is a blue giant, one of the hottest and most luminous types of stars in the universe, which only amplifies the planet's extreme conditions. The intense heat causes Kelt 9b's atmosphere to expand dramatically, creating a puffy, bloated envelope of gas that's constantly being stripped away by the star's powerful stellar winds. It's a planet that's literally being cooked alive, with its atmosphere evaporating into space at an alarming rate. But the heat doesn't just affect the planet's atmosphere, it also influences its very structure. Kelt 9b is a gas giant, similar in size to Jupiter, but its extreme temperatures cause its molecules to behave in unusual ways. For instance, the planet's atmosphere contains traces of iron and titanium, elements that are typically found in stars rather than planets. These metals exist in their atomic form, floating freely in the atmosphere, which is something we've never observed on any other planet. This unique composition makes Kelt 9b a fascinating laboratory for studying how matter behaves under such extreme conditions. What makes Kelt 9b particularly hostile is not just its heat, but the way it interacts with its star. The planet is tidally locked, meaning one side always faces the star while the other remains in perpetual darkness. The day side, exposed to the star's full fury, reaches temperatures hot enough to vaporize metals, while the night side, though cooler, is still incredibly hot by planetary standards. This stark temperature contrast creates violent winds that race across the planet, further destabilizing its atmosphere. It's a world where the very air is being torn apart, making it one of the most extreme and inhospitable environments ever discovered. Kelt 9b challenges our understanding of what a planet can be. It's a place where the boundaries between planets and stars blur, where heat and radiation reign supreme. Its discovery forces us to rethink the limits of planetary survival and the diversity of worlds that exist in the universe. As we continue to study this sweltering giant, it serves as a reminder of the incredible extremes that space has to offer. What other fiery worlds are waiting to be discovered? The search continues, and the universe never ceases to amaze. Now turning our attention to a world that could easily be mistaken for a cosmic jewel, we encounter J1407b, a planet whose ring system is so vast it makes Saturn's iconic rings look like a mere trinket. This exoplanet, located over 430 light-years from Earth, boasts a ring system 200 times larger than Saturn's, stretching across a mind-boggling distance of nearly 120 million kilometers. To put that into perspective, if J1407b's rings were placed around Saturn, they would dominate our night sky, appearing larger than the full moon. But how did astronomers discover such a colossal ring system, and what does it tell us about the mysteries of planetary formation? The discovery of J1407b's rings came about through a phenomenon known as stellar occultation. As the planet passed in front of its host star, astronomers observed a series of complex dips in the star's light. These dips weren't the simple, predictable patterns typically seen during planetary transits. Instead, they revealed an intricate web of shadows, suggesting the presence of a massive and highly structured ring system. This observation was groundbreaking, as it marked the first time a ring system outside our solar system had been detected with such clarity. The sheer scale of these rings challenges our understanding of how such systems form and evolve. The composition of J1407b's rings is another fascinating puzzle. While Saturn's rings are primarily made of ice and rock, the rings of J1407b are thought to consist of a mix of dust, gas, and possibly even larger debris. Some scientists speculate that these rings may also contain moonlets, small, moon-like bodies that orbit within the ring system, creating gaps and intricate patterns. These moonlets could be the building blocks of future moons, offering a glimpse into the early stages of satellite formation around giant planets. The presence of such a complex ring system suggests that J1407b is a young planet, still in the process of shaping its cosmic neighborhood. What makes J1407b's rings particularly intriguing is what they reveal about planetary formation. The sheer size and complexity of the ring system indicate that the planet itself is likely a gas giant, similar to Jupiter or Saturn, but on a much grander scale. The rings may have formed from the remnants of a protoplanetary disk, the swirling cloud of gas and dust that surrounded the young star during its early stages. Over time, gravitational forces sculpted this material into the vast rings we see today. Studying J1407b provides astronomers with a unique opportunity to understand how planets and their ring systems evolve over billions of years. J1407b is more than just a planet with impressive rings. It's a window into the dynamic processes that shape planetary systems. Its discovery reminds us that the universe is full of surprises, and even the most familiar phenomena, like ringed planets, can take on extraordinary forms in distant star systems. As we continue to explore the cosmos, who knows what other breathtaking ringed worlds we might uncover? The search for these celestial marvels is far from over, and each discovery brings us closer to understanding the grand tapestry of the universe. Now shifting our gaze to a world that feels like it belongs in the depths of a cosmic freezer, we encounter Ogle 2005 BLG 390LB, a frozen exoplanet that redefines the meaning of cold. Located an astonishing 20,000 light-years from Earth, this distant world is one of the chilliest ever discovered, with surface temperatures plummeting to just a few degrees above absolute zero. To put that into perspective, absolute zero is the coldest possible temperature in the universe, where all molecular motion stops. On Ogle 2005 BLG 390LB, the cold is so extreme that even the faintest hint of warmth is a distant dream. This frozen planet orbits its host star at a distance so vast that it takes an incredibly long time to complete a single orbit. Its remote location places it far beyond what we consider the habitable zone, the region around a star where liquid water could potentially exist. Yet, despite its icy exterior, scientists have pondered whether life could somehow survive in such a hostile environment. While the surface is likely a barren, frozen wasteland, some speculate that beneath its icy crust, there could be hidden oceans kept liquid by internal heat or tidal forces. These subsurface oceans, if they exist, might provide a refuge for microbial life, much like the icy moons of Jupiter and Saturn in our own solar system. When compared to other icy worlds, Ogle 2005 BLG 390LB stands out not just for its extreme cold, but also for its unique formation. Unlike planets that form closer to their stars, this frozen world likely originated in the outer reaches of its planetary system, where temperatures are low enough for ice and frozen gases to dominate. Its discovery challenges our understanding of planetary diversity, showing that even in the coldest, most remote corners of the galaxy, planets can take on forms that defy our expectations. The study of Ogle 2005 BLG 390LB also raises intriguing questions about the potential for life in the universe. If life can exist in the subsurface oceans of icy moons like Europa and Enceladus, could similar conditions exist on this distant exoplanet? While the answer remains uncertain, the possibility keeps scientists intrigued. This frozen world serves as a reminder that life, if it exists beyond Earth, might thrive in the most unexpected places, hidden beneath layers of ice in the darkest reaches of space. As we continue to explore the cosmos, Ogle 2005 BLG 390LB stands as a testament to the incredible diversity of exoplanets. Its icy surface and distant orbit challenge our assumptions about where life might exist and how planets form. Each discovery like this one brings us closer to understanding the vast and varied tapestry of the universe, reminding us that even in the coldest corners of space, there are still mysteries waiting to be uncovered. Now shifting our focus to a world that feels like it was plucked straight out of a science fiction nightmare, we arrive at HD 189733b, a planet where the weather is as deadly as it is bizarre. This exoplanet, located 63 light-years from Earth, is infamous for its extreme atmospheric conditions, where winds scream across the surface at speeds of 5,400 miles per hour. To put that into perspective, these winds are more than 7 times the speed of sound, making even the most violent storms on Earth seem like a gentle breeze. But that's not all. This planet's skies rain molten glass sideways. Yes, you heard that right, glass. And it's not just falling from above. The the ferocious winds blast it horizontally, creating a relentless, scorching storm that would obliterate anything in its path. What makes HD 189733b even more striking is its deep blue color, reminiscent of Earth's oceans when viewed from space, but don't let its serene appearance fool you. This hue comes not from water, but from the scattering of light through its silicate-rich atmosphere, which is filled with tiny particles of molten glass. These particles scatter blue light, giving the planet its striking color while hiding the chaos that lies beneath. It's a beautiful yet terrifying reminder that appearances in space can be deceiving. The extreme weather patterns on this exoplanet challenge our understanding of atmospheric dynamics. On Earth, weather systems are driven by temperature differences, air pressure, and the rotation of the planet. But on HD 189733b, the rules are completely different. Its close proximity to its host star creates a tidal lock, meaning one side of the planet is perpetually scorched by the star's heat, while the other side remains in eternal darkness. This extreme temperature difference fuels the planet's supersonic winds, creating a chaotic and hostile environment unlike anything we've ever seen. Scientists are particularly fascinated by how such a planet could form and maintain its atmosphere under such extreme conditions. The presence of molten glass rain suggests that the planet's atmosphere is rich in silicates, which are vaporized by the intense heat and then condense into droplets as they cool. This process, combined with the planet's relentless winds, creates a cycle of destruction that defies our current models of planetary atmospheres. It's a stark reminder that the universe is full of phenomena that push the boundaries of what we think is possible. HD 189733b also raises intriguing questions about the diversity of exoplanets. If a planet can have sideways glass rain and supersonic winds, what other extreme weather patterns might exist out there? Could there be worlds with diamond hail or planets where storms last for centuries? Each discovery like this one expands our imagination and challenges us to rethink what we know about the cosmos. As we continue to explore the universe, HD 189733b stands as a testament to the incredible and often terrifying diversity of exoplanets. Its extreme weather, stunning color, and unique atmospheric dynamics remind us that the universe is far stranger and more wondrous than we could ever imagine. And with every new discovery, we're reminded that the cosmos is full of surprises waiting to be uncovered. Now turning to a world that feels like it's still in its infancy, we encounter K233b, one of the youngest exoplanets ever discovered. At just 5 to 10 million years old, this planet is a cosmic newborn compared to Earth, which has been around for over 4.5 billion years. Imagine a planet so young that it's still in the early stages of its formation, offering us a rare glimpse into how solar systems are born and evolve. K233b orbits a young star in the upper Scorpius region, a stellar nursery teeming with newly formed stars and planets. Its youth makes it a treasure trove for scientists studying planetary formation. Unlike older exoplanets, which have settled into stable orbits and atmospheres, K233b is still a work in progress. Its discovery challenges our understanding of how quickly planets can form and what conditions are necessary for their survival in the chaotic early stages of a star system. One of the most fascinating aspects of K233b is its close orbit to its host star. It completes a full revolution in just 5.5 Earth days, meaning its year is shorter than a week on our planet. This proximity suggests that the planet formed much closer to its star than previously thought possible, raising questions about the mechanisms that allow planets to take shape in such extreme environments. Could this mean that planets can form faster and closer to their stars than we once believed? The answer lies in the ongoing study of this young world. The discovery of K233b also sheds light on the early stages of planetary atmospheres. While older exoplanets often have thick, stable atmospheres, this young planet's atmosphere is still developing. Scientists believe it may be losing material to space as it interacts with the intense radiation from its star. This process, known as atmospheric escape, could help us understand how planets like Earth retain their atmospheres over billions of years. By studying K233b, we're essentially looking back in time to the early days of our own solar system. What makes this exoplanet even more intriguing is its potential to challenge existing models of planetary migration. Some theories suggest that planets form farther out in a star system and then migrate inward over time. However, K233b's close orbit suggests that it may have formed right where it is, defying these traditional models. This discovery opens up new possibilities for how planets come to occupy their positions in a star system, reshaping our understanding of planetary dynamics. As we continue to explore the universe, K233b serves as a reminder of the incredible diversity of exoplanets. Its youth offers a unique window into the processes that shape planets and solar systems, providing invaluable insights into the origins of worlds like our own. Each discovery like this one brings us closer to understanding the complex and dynamic nature of the cosmos, reminding us that the universe is full of surprises waiting to be uncovered. Now shifting our gaze to a world that's literally being consumed by its own star, we arrive at WASP-12b, an exoplanet that's living on borrowed time. This ultra-hot Jupiter is one of the most extreme planets ever discovered, and its fate is as dramatic as it is inevitable. Orbiting perilously close to its host star, WASP-12b is being slowly torn apart, offering us a front-row seat to the violent processes that can shape and destroy planets. What makes WASP-12b so unique is its distorted shape. Unlike the spherical planets we're familiar with, this exoplanet is stretched into an egg-like form due to the immense gravitational forces exerted by its star. These tidal forces are so powerful that they're literally pulling the planet apart, a process known as tidal disruption. Over time, this relentless tug of war between the planet and its star is causing WASP-12b to lose mass, with some of its material being siphoned off into a swirling disk around the star. It's a cosmic dance of destruction, and one that's happening right before our eyes. The proximity of WASP-12b to its star is staggering. It completes an orbit in just over one Earth day, meaning its year is shorter than a weekend on our planet. This close relationship comes at a cost, though. The planet's surface temperatures soar to over 2,000 degrees Celsius, making it one of the hottest exoplanets ever discovered. To put that into perspective, that's hot enough to vaporize most metals. The intense heat and radiation from the star are not only warping the planet's shape, but also stripping away its atmosphere at an alarming rate. Scientists estimate that WASP-12b could lose a significant portion of its mass within the next 10 million years, a blink of an eye in cosmic terms. But what does this mean for our understanding of planetary life cycles? WASP-12b is a stark reminder that planets are not eternal. Just as stars have life cycles from birth to death, so too do planets. The fate of WASP-12b illustrates how gravitational interactions can dramatically alter a planet's trajectory, leading to its eventual demise. This process isn't unique to WASP-12b. Similar tidal forces are at play in other star systems, including our own. For example, Jupiter's moon Io experiences intense tidal heating, causing it to be the most volcanically active body in our solar system. But in the case of WASP-12b, the stakes are much higher as the planet is being consumed entirely. The study of WASP-12b also raises intriguing questions about the diversity of planetary systems. How common are planets like this? Are they a rare anomaly, or are they more widespread than we realize? By observing WASP-12b, scientists are gaining valuable insights into the extreme environments that can exist in the universe and the forces that shape them. This exoplanet serves as a cosmic laboratory, allowing us to test our theories about planetary formation, evolution, and destruction. As we watch WASP-12b's slow but inevitable demise, we're reminded of the dynamic and ever-changing nature of the universe. Planets are born, they evolve, and sometimes they meet dramatic ends. WASP-12b's story is a testament to the incredible forces at play in the cosmos, and it challenges us to rethink what we know about the life cycles of planets. Each discovery like this one brings us closer to understanding the complex and often violent processes that govern the universe, reminding us that even in destruction, there is beauty and knowledge to be found. Now, as we bring our journey through these bizarre exoplanets to a close, we turn our attention to one that holds a special place in the search for life beyond Earth, Proxima Centauri b. Nestled within the habitable zone of Proxima Centauri, the closest star to our solar system, this exoplanet has sparked immense excitement among astronomers and dreamers alike. Why? Because it sits in that sweet spot where liquid water could exist, a key ingredient for life as we know it. Proxima Centauri b orbits its red dwarf star at a distance that allows for temperatures that might support liquid water, but it's not without its challenges. Red dwarfs, while smaller and cooler than stars like our Sun, are known for their volatile nature. They frequently emit powerful stellar flares which can bombard nearby planets with intense radiation. This raises questions about whether Proxima Centauri b's atmosphere could survive such harsh conditions, or if it could even develop one in the first place. Despite these hurdles, the planet remains a prime candidate in the search for extraterrestrial life, simply because it's so close, just over 4 light-years away. That's practically next door in cosmic terms. What makes Proxima Centauri be even more intriguing is its potential for tidal locking. Like many planets orbiting red dwarfs, it may have one side perpetually facing its star, creating a stark contrast between a scorching day side and a frigid night side. Yet, even in such extreme conditions, life could find a way. Scientists speculate that a thick atmosphere or vast oceans could redistribute heat, creating a narrow band of habitability along the planet's twilight zone. It's a tantalizing possibility that keeps researchers eagerly studying this world. The discovery of Proxima Centauri b also highlights the importance of red dwarfs in the search for life. These stars make up the majority of stars in our galaxy, and their long life spans trillions of years compared to the Sun's mere 10 billion, mean they offer stable environments for life to potentially evolve over vast stretches of time. If Proxima Centauri b or other similar planets can overcome the challenges posed by their fiery hosts, they could be teeming with life waiting to be discovered. As we reflect on the 20 exoplanets we've explored, from the diamond-studded 55 Cancri E to the molten iron rains of WASP-76b, and now to the potentially life-friendly Proxima Centauri b, one thing becomes clear: the universe is far stranger and more diverse than we ever imagined. Each of these worlds challenges our understanding of what planets can be, pushing the boundaries of science and sparking our curiosity about what lies beyond our solar system. Proxima Centauri b, in particular, reminds us that the search for life is not just about finding Earth-like worlds, but about understanding the incredible adaptability of life itself. So, as we conclude this journey through the cosmos, we're left with a sense of wonder and anticipation. Which of these bizarre exoplanets fascinates you the most? Could Proxima Centauri b be the key to answering one of humanity's oldest questions? Are we alone in the universe? Let us know your thoughts in the comments below, and don't forget to subscribe for more deep dives into the mysteries of space. The universe is vast and the discoveries are just beginning. As we wrap up this cosmic journey, let's take a moment to reflect on the incredible diversity of the 20 bizarre exoplanets we've explored. From the diamond-studded surface of 55 Cancri E to the molten iron rains of WASP-76b, each of these worlds has pushed the boundaries of what we thought was possible. The Puffy Planet HDP-1b defied our understanding of planetary density, while the dark planet TRS-2b left us questioning how a world could absorb almost all light. The water world GJ1214b challenged our ideas of habitable zones, and the rogue planet CFPD SIR 2149-0403 made us rethink how planets can exist without a star. Each discovery has not only expanded our knowledge but also deepened the mystery of the universe. These exoplanets remind us that space is far stranger and more varied than we could have imagined. They challenge our assumptions, spark our curiosity, and inspire us to keep exploring. Whether it's the glass rain of HD 189733b, the super puff cotton candy density of Kepler 51b, or the tidal forces slowly devouring WASP 12b, every world tells a story of extremes and possibilities. And then there's Proxima Centauri b, a tantalizing glimpse of a potentially habitable world right in our cosmic backyard. Together, these discoveries paint a picture of a universe that is endlessly surprising and full of wonders waiting to be uncovered. So, which of these bizarre exoplanets captured your imagination the most? Was it the Diamond Planet, the Lava World, or perhaps the enigmatic Proxima Centauri b? Let us know in the comments below. We'd love to hear your thoughts. And if you've enjoyed this journey through the cosmos, don't forget to subscribe and hit the notification bell for more deep dives into the mysteries of space. The universe is vast and the discoveries are just beginning. Until next time, keep looking up. You never know what incredible worlds might be waiting to be